Let's look at the extreme value theorem. If we've got a function that's differentiable over the interval a and b, so we've got a and b, and we've got two other values, c1 and c2. This is also an element of a and b, the function. And we've got a value where the function of fc1, which is a maximum at that point, is between maximum and the minimum. So this means that the function is between the maximum value and the minimum value. If we've got this scenario, and x is an element of a and b, and f is differentiable over the a and b, then the point c1 and c2 is either the maximum or minimum, or the first derivative of the function is with the first derivative is equal to 0, which is the maximum or minimum point, that would be the minimum or maximum. So what this means is, if we've got a graph like this, then you'll see that the points a and b in this case is the minimum maximum and not the first derivative. So we use the extreme value theorem to determine the minimum and maximum of over a specific interval. So let's look at an example. Let's look at the function. And we've got a function, let's write it down. The function is 2 minus e to the power of x plus 2x divided by 3. And we've got an interval of 0 and 1. So we want to determine the minimum and maximum value of this function. So one way to write this down is, we've got a value between 0 and 1 of the absolute value of fx. So we want to basically determine what the maximum value of this function. So we need to determine what is the values of the extremes. So we need to find out what's the value at a and at b, which is the endpoints of our graph. And we also need to find the first derivative of the function, and then see at that value, where's the first derivative is equal to 0. When we get the answer of x, we then substitute that value into f as well to find out if this is a minimum or a maximum value. So let's look at this example. If we substitute so let's start with the first derivative. So the first derivative of this function would be, so this is 2/3, let's just write it as this, minus e over x divided by 3 plus 2x divided by 3. This is the x, this is not the first derivative. So if we get the first derivative of this function, that will be 0. This would be just e to the power of x divided by 3, and this will just be 2 over 3. So this is the first derivative. And if we need to solve this, so we need to equate this to 0, then minus e to the power of x would be equal to minus 2, or e to the power of x is 2, and then we do ln on both sides, and x would be ln of 2. So this means that at x equals ln 2, we would get the turning point, the minimum or maximum value of this graph. So if we've got a graph, we'll get a minimum maximum. Now we also need to find out what is the value at the endpoint. So what's f if we substitute 0? So this would be 2 minus e to the power of 0 plus 2 times 0 divided by 3, which would be, this will become 1. So it's 2 minus 1 over 3, which would just be a third. Okay, if we do the same for 1, we will have 2 minus e to the power of 1 plus 2 times 1, which is just 2 over 3. And this will be equal to 4 minus e. Okay, let's just write it over. Let's just go to the next page. So if 1 would be 4 minus e divided by 3, which would be more or less 0.427239 if you put it into a calculator. And f in 0 would be 1/3, which is 0.3 repeated. Okay, so now we know that we also need to find out what is the value of ln2. So this is the turning point that we calculated here. You'll see where the first derivative is equal to 0. So it's got one turning point at ln2. Now we substitute that ln2 into the equation. And then we get 2 minus e to the power of ln2 plus 2 ln2 divided by 3. So e ln2 is just 2, so it's 2 minus 2, so the answer would be 2 over 3 ln2. And we get the answer here, it would be 0.4621. Okay, so if we look at this, we've got 3 points, 0.42, 0.3, and 0.621. So we'll see that the turning point of this graph is actually where the maximum value is. So we can say the maximum value of 0 between x and 1 of fx is equal to 0.4621. So we used the extreme value theorem to determine what the minimum or maximum value would be of a specific graph. We can do the same calculation on